I know the universe started with a really big explosion.
No.
That's a good start. You're wrong.
You're wrong. The universe did not start with an explosion. The Big Bang is not an explosion.
All right. Okay, so if it's not an explosion, what is it?
An expansion, an extremely rapid expansion.
Okay, I'm gonna nod and acknowledge that's not quite the same thing.
It's not though.
All right. So what did it look like then?
To be perfectly honest, we don't really know. We can't see it.
Okay, but there's like light coming in from all sorts of distant stars. I know that when you look at stars that are a long way away, you're looking back in time, right? Because the
Yes.
light's travel a certain distance to us, and it takes time. So
Absolutely.
why can't we just look back? What is it, 13.8 billion years to when the Big Bang happened, and just look?
Because it turns out that there's a limit to how far back we can look, and because the universe wasn't transparent.
Well, that's just jolly inconvenient.
Yeah, it really is. I mean, right now the universe is transparent to light, mostly. I mean, the Earth isn't transparent to light, the sun isn't transparent to light, but most of the universe is not filled with stuff. And it's transparent. If there's a distant star, we can see it. If there's a distant galaxy, we can see it. We can look back, hundreds or millions or billions and billions of light years, like Carl Sagan said, because the universe is transparent to light. But as you go farther back, the universe is smaller and smaller because the universe has been expanding. So if you go back in time, the universe is smaller than it is now. As it gets smaller and smaller, it gets denser and denser and hotter. And there's a point in time, if you go back far enough, and it's very, very far back. It's only 380,000 years after the Big Bang, which, given that we're 13.8 billion years after the Big Bang, that's a lot closer to the Big Bang than we are now. But if you go that far back, the universe is so hot and so dense that light can't travel through it anymore.
Okay. All right, fine. So we can't see using normal light, but don't we have like radio telescopes and X-ray telescopes? And don't we look at all sorts of other different kinds of radiation? Is it not transparent to that either?
No, it's not transparent to any form of electromagnetic radiation, any kind of light. If you look at the sky in microwave, radio, you can actually see radio waves coming from all directions, and it's actually the earliest light in the universe. It comes from that point in time, 380,000 years after the Big Bang, when the first light was able to pass through the universe freely, when the universe became transparent. And that light is called the cosmic microwave background radiation.
All right, so we can't see back with any kind of light or electromagnetic radiation, but are there any traces left from before that 380,000 year barrier?
Maybe the most interesting thing left over is it turns out there's also a cosmic gravitational wave background.
Okay, and for those of us that are beginners, what's a gravitational wave?
So gravitational wave is a wave in space-time itself.
A ripple, right?
Yes, a ripple in space-time itself. It's like that old book, A Wrinkle in Time.
Okay.
That ripples through the fabric of space-time itself. And they're very, very hard to detect. And we're never probably going to be able to directly detect these gravitational waves from the Big Bang. The way that we directly detected these gravitational waves from these black holes merging was a huge deal, and it was amazing, and I cried, and it was awesome. We're not going to be able to do that. We're not going to be able to do that with gravitational waves from the Big Bang. We're not going to see them directly like that, but they may have left an imprint in the cosmic microwave background radiation. They may have left a little signature in there. And in fact, that's what the BICEP group down in Antarctica, they thought they saw that. But then it turned out that it was, they couldn't tell if they were actually seeing that or if it was just dust in the foreground from our Milky Way.
That sounds very disappointing.
Yeah, it is very disappointing. But they're still working on it. And if they see that, or if somebody else sees that, that could be the oldest radiation, the oldest stuff that we can see in the universe. It could be information that we get about the first fraction of a fraction of a fraction of a second after the Big Bang itself. That would be completely amazing.